Good afternoon, everybody, or morning, or evening, or wherever you're from. Good to see you all. This is episode number 71, in which we're going to be exploring some of the new features and capabilities of the Cilium CLI, because I'm personally pretty impressed with it. So we're gonna play with that a bit this episode, and then next episode we'll probably dig a little. We'll play a little bit with the KubeVirt environment that we set up last time, kind of that cluster API mechanism. We're going to play with a few things, and yeah, let's get into it. Should be a lot of fun. As usual, if you're out there, let me know in the comments that you're tuned in. I'd love to say hello, see what you all are up to. Again, as usual, let's kick off with the eCHO news. And remember that if you wanted to go look at the notes that we have inside of this particular setup. Oh, I just realized I haven't published this. Whoops, 1 second. Let's see, where's that? Share. This is 071. Save. Okay, so now it's published. And so you can go to that URL here on the bottom right-hand corner, hackmd.io/echo live, and you will be able to see the episode notes in the chat. But I will also go ahead and put them in the chat so that you'll be able to just click on them. All right, there we go. If in the eCHO news you would like to subscribe, you can see a subscribe button way down at the bottom. Right here, we can see. If you're not already subscribed, then you'll see the subscribe piece, or you can click this sign up today button right here. Okay, let's get into the news. See what we got going on this week. Lots of good stuff. Reminder that this news is gathered by a bunch of folks here at ISOBIL in the community, and also Mr. Bill Mulligan gathering a bunch of information. So really great stuff. This was the end of Thanksgiving. How we diagnosed and resolved Redis latency spikes with BPF and other tools. Very cool. Using BPF trace to resolve performance issues. A good example of that. eBPF networking node port, the POC of Kate's node port service using eBPF. This is something we've actually had solved inside of Cilium for some time. A tiny firewall built using Rust. Neat. SK lookup. And then we have eBPF T-proxy splicer, an eBPF program that uses eBPF to TC to redirect ingress IPv4 UDP TCP flows toward specifically dynamically created sockets using OpenZD edge router. That is complex. Mr. Steve Sloka, so good to see you, man. I wonder how you've been. It's very, very, I feel like I haven't seen you in forever and ever, but very good to see you. Kindling project, eBPF-based cloud-native monitoring tool. Haven't looked at that one too much. BPF for HID devices. Interesting. Why public cloud vendors must get more serious about it. I feel like, some public cloud vendors are pretty serious about it. We got to see Purvey from Google talk about it and talk about their interest in it at eBPF Day at KubeCon in Boston. I thought that was really great. I'm doing great. I'm enjoying life, enjoying the, learning out loud and doing all that stuff. What else we got? We have an IETF hackathon. Even the IETF wants to get on the eBPF. Harnessing the power of eBPF. Yet another eBPF company. And then the how-to. Transparent. Oh, I actually just saw this one. This looks like a great how-to if you're deploying into an EKS cluster and you want to leverage Cilium and WireGuard to encrypt all traffic back and forth transparently. This is a great how-to and how to go about that. That was put up by Mr. Aaron Miller and Mr. Rajdeep Saha. Aaron is a good friend that worked with Steve and I at Heptio and has gone on to AWS. So great article by Mr. Aaron and Mr. Rajdeep. So if you're interested in this, definitely check that out. It's a great solution. It's a great overview. I think they did a great job with it. So they're going to be using Helm to the install. This is an interesting one. Yeah, looks good. Should be very cool. You have Kubernetes networking, security, and observability with Cilium and more. Another great event, Cilium hands-on, Cube Day Japan. And actually, I don't know if you just noticed it, but earlier today in, I guess, world clock time, we had our very first episode. That was a Japanese eCHO episode, and it was hosted by Utaro, and I believe Michi was there as well. So that should be pretty cool. I haven't checked that one out myself yet, but I'm looking forward to tuning into it. Yeah, eBPF and the Japanese community. And then the tweet of the week: Berkeley Packet Filter is a subsystem of many Unix operating systems wherein all packets are sent to a server in Berkeley, right? That's hilarious. In Berkeley, California, which has firewall rules on it. Seems legit. Berkeley sockets. Oh, so good. Yeah, that's clearly not the case. Anyway, hilarious. I love it. So let's jump into our topic for the day. And we're going to be looking at the Cilium CLI. So I wanted to bring this up. This is where you can find the Cilium CLI. So it's in GitHub underneath the Cilium project, labeled the Cilium CLI. And the Cilium CLI does a lot of really interesting things, but specifically it does an install of Cilium, and it also handles some of the other capabilities of managing Cilium, like doing Cilium upgrades, grabbing a system, which is kind of like a big debug tar file that allows us to understand how Cilium is operating in your environment. Hello, Dariush. Very nice to meet you. Live. Oh, fair. Good point. World Cup is still happening. Go Brazil. So it handles the install, it handles upgrades, it handles doing connectivity tests, it handles doing some performance analysis and performance testing of Cilium inside of your environment. It does a lot of, and then in the install piece specifically, it actually does some pretty interesting stuff. So I thought today would be a great opportunity for us to kind of work through what it does and to kind of show you like some of the new features of the Cilium CLI. If you're curious about tracking the features in the Cilium CLI, you can click on the releases and you can actually see what's changed, and it's written up pretty well on how to go about that, or how it's written up pretty well by release, talking about what's available here. So if we go to the actual releases, we can see a bunch of new capabilities have been added over time. I'm not going to dig into that here because we're actually just going to play with it and see how it works. So let's go ahead and kick that off. First thing I'm going to do is I'm going to go ahead. I don't think I have any kind clusters running at the moment. Get clusters. Oop. That's what I wanted to add. I forgot that one. You should never do this, by the way. This is a terrible way to handle this problem. You should just install the completion file somewhere. Clear kind get clusters. Much better. Okay, so there's no kind clusters. So just like we did in our last episode, I'm going to go ahead and bring up a kind cluster and do a Cilium install into it. And we're just going to see how that works, just kind of out of the box. So this is my kind configuration, and I have one kind control plane node and one worker node, and I've pinned them to version 1.24.4 of the of Kubernetes. And you can see that I've also got some extra mounts. We'll talk about why that is here in a little while, but first I'm just going to make it happen. And what this is doing, this is kind of like Docker in Docker, but I'm not actually, maybe kind of using Docker in Docker, but you get the idea. I'm going to mount the Docker socket from the host into the container and make it so that that is available to processes that are running inside of that kind node. And we'll talk about what's happening there as we proceed. But first, let's go ahead and bring up this kind cluster. Create cluster config kind. And this will create a 2-node cluster pinned to that version that we just talked about. And because of this part of the configuration right here, Oh, well, let me highlight. Boop, boop, boop. Anyway. Oh, because the text is actually happening. That's why. So because of this part of the configuration right here, what's happening is it's going to be installed without a CNI. And that's where we will use Cilium to do the install. And this will be the first part of the example of doing that. So let's get this go ahead and installed. So now we have our 2-node cluster. And if I were to do kubectl get pods -a, we can see that we have a cluster deployed. The core DNS is not running, and kubeproxy is there. Local path provisioner is not running. I'll get nodes. We can also see that there is no CNI installed, right? So there's no CNI pods running anywhere, and the 2 nodes are sitting in not ready state. And that's pretty normal configuration for a cluster with no CNI. So let's first do a Cilium install and talk about what we see. So it auto-detected the cluster name, kind cluster. It auto-detected a data path mode of tunnel. It auto-detected that kubeproxy has been installed. And then it outputted this command, right? And this command is basically how the Cilium CLI will go about determining. Oh, actually, there's one more thing it did before we go further. It also auto-detected that the Kubernetes version was a kind cluster and running the kind validation checks, and then detected that the kind version is a 0.14. And so we install Cilium version 1.12.2. So then it output this command just for information. And this command is basically how it will go about generating the manifests that will be used to install Cilium into this cluster, right? So we can see the parameters that it automatically detected and what it's going to go about doing inside of this cluster. So by default, it will install into the kube system namespace. The release will be called Cilium. It's going to install the Cilium helm repo at version 1.12.2. And then it will set the cluster ID to 0. This is a mechanism for things like cluster mesh. It will set the cluster name to kind cluster. The encryption will be set to false, which I think is already the default. It will set the IPAM mode to Kubernetes. It will set kubeproxy replacement to disabled because it found that kubeproxy was deployed. It will set the operator replicas to 1 because it's a kind cluster. And then, the rest of this, right? It's creating the service accounts and then setting the tunnel to VXLAN. It stores all of these values in a secret instead of kube system, Cilium CLI helm values, so that it can reference those later if we decide to do an upgrade. And it goes about creating all of the things. It creates a CA and called the Cilium CA. It generates certificates for Hubble, creates the service accounts, creates the config map for the Cilium version 1.12.2, creating the agent daemon set, creating the operator deployment, and then waiting for it to be ready. And then once it's all ready, we can do a Cilium status, and we can see that things are deployed correctly. Now, if I were to do kubectl get proxy or kubectl get pods -a, I can see that Cilium is installed with its operator, and I have one on each of my nodes, but I don't see any Hubble or any of that stuff deployed yet. The Cilium CLI can handle that install as well. So if I were to do Cilium Hubble enable, then we can see the command that happens next. Helm template. It's going to grab the CA cert. It's not going to output the CA key because redacted when printing to terminal. If you want to print the certificate key to terminal, you can actually say keys to false. Basic security feature. And then we can also enable the UI. And now that cluster should have all of the components of Cilium and Hubble deployed. So if we do you know what, that's a bug. Haha, we have found a bug. Cilium Hubble, unable to enable Hubble, services Hubble peer exists. So I'm going to go ahead and work around this for now. Delete service and kube system Hubble peer. We have found a bug in the latest version of Cilium. So I wonder if we had just done the install of, Cilium Hubble UI, if that would actually have done the thing that we were kind of expecting to happen. Possibly, but we'll explore that another time. So here you can see pods A, we have our Cilium cluster. We have Hubble Relay deployed. We have Hubble UI deployed. Everything is working pretty well there. All right. The next thing I want to do is basically we talked through like that basic configuration above. We talked through what's actually happening with Cilium CLI. There are a few other things that Cilium CLI can do, including give you batch completion or a different shell completion. But now that I have Cilium deployed, maybe I want to view the config. This is the output of the config map that is used to configure Cilium directly. And you can actually see all of the values that were generated and what the configuration of all of those things are at the moment. So for example, that IPAM Kubernetes piece, we can see that piece here, and then we can see the Q proxy replacement is set to disabled. All of that configuration, the tunnel mode is a VXLAN, all of that configuration basically being parsed from the helm values that we saw in our install earlier, right? So there we go. If we wanted to change a configuration, Cilium config will allow us to change that configuration, right? So if we wanted to set the VXLAN, we wanted to set the tunnel mode to a different encapsulation, or we want to set the monitor aggregation differently, or we want to turn on other capabilities, we can actually do that just with a Cilium config set command. And when it makes the change to the config map, the Cilium config will also, or the Cilium CLI will also restart all of the Cilium agents to reflect that change. Let's go ahead and do a couple other things. Let's do Cilium. Well, okay, so that is partially what I wanted to show you. There's another one that I wanted to show you, another command that has actually just recently been provided that I want to show you real quick, which is the Cilium install generate helm autogen values test.yaml. So this is going to do all of the auto detection. It's going to generate all of the values for that particular target cluster that it has detected, and it will output this file without making any changes to the cluster. It will output this file, which is basically a values file that can be used to do a helm install of Cilium into your target cluster. So if I wanted to use that auto detection functionality of Cilium, then I could, to determine like how to configure my target cluster, right? Then I could actually I could generate a values file by using this mechanism here, right? Cilium install helm autogen values, and then provided an output. And that values file is basically a starting place for helm install. Cilium version 1.12.2 values. So that would be kind of the equivalent of what we saw above. The difference being that in this particular context, if I were to go this path, then I would actually have a helm release managing Cilium rather than just using the Cilium CLI to manage it. All right. Hope that all makes sense. That's pretty interesting stuff to me. So the next thing I'm going to do is I'm going to go ahead and bring the rest of this cluster up. My intention is to bring this up as a cluster API environment because I'm going to be spinning up a couple of different clusters to show you the different capabilities of the Cilium CLI's auto detection capability stuff. So let's go ahead and do that. I'm going to go ahead and vim my install.sh here. was already commented out. So what this install.sh is going to do is it's going to do very similar to what we saw in our last episode, where I'm going to deploy kubevip. I'm going to make sure that this is the correct network. I'm going to go ahead and install the kubevip RBAC manifests. Then I'm going to go ahead and deploy the kubevip daemon set. And then I'm going to come down here and install the kubevert operator and kubevert custom resource set. And then it'll wait around for those things to be installed. And then we'll go ahead and we'll do our cluster kettle init. So let's go ahead and do bash install.sh. Oh, there's one more thing I wanted to check there. This Docker. Nodes dash wide 3218. Good. So the reason that's important, just look back at that install script real quick. I just want to show what I'm doing here. And I did talk about this in my most recent episode when we were evaluating cluster API. But you can see the network, the Docker network being used by the client clusters is this 172.18.03 network. And I'm going to use a portion of that whole network, 172.18.110 to 172.18.130, as a range for VIPs to be used by kubevip, so that when I create a service of type load balancer, kubevip can actually expose that in a way that's reachable to me from within this cluster. Okay. Connected, that was silly. Yeah. -8W. All right. So it looks like everything is created and running. Oh, there we go. Condition met. So we just checked kind of right at the moment when things were finishing up. Okay, install sh. So the other thing I want to do, the next thing I want to do, I should say, is go ahead and do our cluster kettle init. Init infrastructure cube owner. Infrastructure providers and versions. Okay, so I think what I want to do next, I want to jump back here and tell you what I'm going to do next. So the next piece is this quick starts piece. My intention is to install 2 infrastructure providers and to manage and to bring up clusters across the 2 different infrastructure providers as we're doing this detection. So we can see the difference in some of the detection that Cilium is going to do. So to do that, what I need to do real quick is look at the way that Cilium cluster kettle init works. Oh, I missed something. There we go. Okay, so the Docker one, infrastructure Docker, and the kubevert one, infrastructure kubevert. Okay, so I think what I don't know is whether it's like comma or space separated. So I'm going to assume space, and we'll see how it shakes out. Cluster kettle. Does it actually say? Infrastructure strings. Yeah, it doesn't have an example of like multiple versions, but we're going to give it a try. Cluster kettle init qbert. Like that. No, it's because it's not called kind. It's called Docker. Bad. Installing certain manager. Installing the kubeadm bootstrapper. Installing capd and capk. Oh yeah, that worked. Okay, so it is comma separated. And it says that it's installing the infrastructure Docker and the infrastructure qbert. Very nice. Okay, so our next step at this point is to go ahead and start creating some clusters. Get machines-a-oy, which at the moment is empty, and that's okay. So the first thing I wanted to show you was my intention here is to go ahead and create two clusters, one with kubeproxy deployed and one without kubeproxy deployed. And I want to take you through how that works with Cluster API. And then we'll use Cilium to do the install on each of those target clusters and show how those pieces kind of function. Let's go ahead and get started there. So the next thing I'm going to do is I'm going to actually go back to that documentation page. And we're going to go ahead and do a cluster kettle generate cluster command with our different providers. First one will be the kind cluster. So we'll do cluster generate. We'll call this proxy. It's in the Docker provider. It's the flavor. We'll create one control plane, one worker machine. We're going to put it in the, let's see, Docker, no proxy namespace, and we'll call it Docker no proxy. Oh wait, no, this one has a proxy, so this will just be kind of proxy. What did I call it? Kind proxy. Kind proxy. Okay. Generate cluster kind proxy, infrastructure Docker, Kubernetes 123.10, control plane, machine count 1, worker machine count 1, -n kind proxy. Let's give that a try. Infrastructure failed to download. Huh. Let's go back to our docs. Figure out what we need to generate that cluster for a kind setup. Ding, 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 ding. Okay, did that. Says I should just be able to manage it. Let's try again without all this stuff. Let's just do real basic here. From the 1.3.0 release. Failed to read cluster template YAML. Kernel. Yeah. Let's see here. Yeah, I think that's what's up. So let's see if we can go find that. Get a release 1.3.0. So if we do, let's see, cluster Kernel. Alpha. Oh. Subscribe. Cluster. Get. No on that one. Let's see. I think what I want to do. I know that somewhere the cluster Kernel is actually holding its configuration. So let's do, what if we just do --verbose -v10. More information. It's trying to, what if we've got the wrong version of this installed? Let's go ahead and take a look. Actually, settings.kdates.io. So I know, because I've chased this particular dragon before, that cluster API Docker is actually hosted inside this repository, unless they moved it around or anything. So then what I want to see is on the releases side, there's 1.3.0. Blah, 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 blah. Bunch of changes. Good. Oh, template type. So if we create a cluster template of type development, then I think this will work. Because do you see the name cluster template type development? Yeah. Okay. Wait, no. What are you doing? Cancel. Oh my God. What? Is it seriously opening this in Notepad? What have I done? My default YAML editor is Notepad. Welcome to the wonderful world. Anyway, all right, let's keep going. So we know that there is actually a default, there's a cluster template development. And if we looked at other releases, we'd probably see that there might be another cluster template, but this is the bug. So let's go ahead and try and work around that. Let's see. Oh, not what I wanted. Or element value for Kubernetes version is not set. Did I not set it? Oh, I guess I took it out. Oh, my bad. There we go. And then flavor development. Boop. And then we take a look at that. Kind proxy. YAML. And then it is able to actually leverage the template that's hosted in that GitHub repository. But I had to actually create type development for it to work. There's no default cluster template YAML. There's only a development cluster template.yaml. All right. So that is going to work. So let's go ahead and do cluster kubectl. So our namespace was kind proxy, kubectl create ns kind proxy, kubectl apply-f kind proxy.yaml. Oh, interesting. So it's complaining at me because I didn't create the cluster topology piece. So if I were to do, oh, I'd have to do, okay, well. All right. Let's just kind delete cluster. All. And let's go ahead and kick this thing off again. So we'll do our kind create cluster again. YAML. Whoa, why are there so many nodes? Oh, I see. Delete clusters. All. Kubert. Create cluster. Config. Nodes. Bear with me while we chase this down. We're almost there. Yeah, it is the version. You are correct, Sergio. Great job. Yeah, and I think you're right. For the Docker provider, I have to have that class exported before I do the cluster kettle of inits. I'm just going to re-kick because it's just a kind cluster. It doesn't take too long to do that. So and then I'm actually going to go ahead and add some stuff to install.sh. And we had Cilium install. Had cluster kettle init infrastructure. Okay. Go bash install.sh. Back up your CAPI management data. That is hilarious. Don't you think that's funny, Mr. Steve Sloka? I want to see Mr. Steve Sloka reply to that. I don't know if he's still watching, but if he is, that'd be amazing. So this question is a great question that is a great fit for a product that we worked on together at Heptio called, what was it called? It was called Valero. And Valero is a great way to manage that. So while we're waiting for all this to kick off, the answer is this great article by my good friend, Scott, using Valero to crack cluster API. So if you want to play with that, that's a great way to do it. It's a great question. Thank you for asking that, Sergio. Yeah, so if you look up Valero cluster-API, that's where you can find that content. Kernel get pause-AW. For the vert controllers, they just went. Now it'll say condition met. Now it's going to do the fetching providers thing because it's going to go ahead and do the cluster kettle install for us. And then we will continue on our interesting path of creating clusters in both kind and also in KubeVirt. Cert manager being deployed. Installing the bootstrap, the kubeadm bootstrapper. Installing capd and capk. Oh, all right. Clear that up a little bit. Clear. kubectl create ns kind proxy. It'll apply -f kind proxy. Mess something up. Oh. There. We had generated a configuration. Haha. All right. Okay. I am going to pop a terminal over here real quick. Fix this problem real fast. Proxy YAML. Alrighty. Let's kick it off. So we will do kubectl apply -f. Actually, let's do kubectl get machines -aw. Should be none. proxy. This time, no errors. There we see our machines. And the other thing I wanted to deploy was a cluster without kubeproxy installed. And this is a neat trick because it's a relatively recent feature. But let's talk through the process for that real quick. To do that, I wanted to look at how I could go about passing parameters into kubeadm, because my goal would be to deploy a cluster without kubeproxy. Kubeproxy, the way kubeadm installs it, is an add-on. It is a function of it's part of the init function of kubeadm. So if you do kubeadm init on a node, there is an add-on called kubeproxy that gets deployed as a daemon set inside of the kubeadm-based cluster. So my intention was to figure out how I could go about setting a different configuration for that so that it would skip the phase for that particular add-on. In the Kubernetes docs, there's a great example of this, right? So kubeadm is a Kubernetes-based project, and you can actually see documentation for kubeadm here. And inside of the example, there is an example for skip phases add-on kubeproxy, which makes it really easy for us to see how that would work. So this is part of the kubeadm init configuration. And we can see that there is a skip phases high-level object, and we can actually pass the different phases that we want to skip in a list. So all of that being said, if I were to do the same cluster kettle generation, we're going to call it no proxy. We're going to call it no proxy. And we're going to give it the name no proxy. I'm just going to go ahead and create that file, and then we'll edit it and make the change that we want to make. So we'll go ahead and do that. Go ahead and create our namespace so that we will be able to use it here in a minute. So we'll create an ns kind no proxy. And let's go ahead and edit that file that we just created called kind no proxy. And inside of here, there will be a kubeadm configuration. This is a security standard. So let's do init. Configuration. There we go. So this is the init configuration that is generated for this cluster, and it is part of the kubeadm control plane template. Inside of that spec, there will be things like kubeadm config spec, applying some local informations, controller manager extra args, enable host path provisioner true, and here is the init configuration. In here is where we want to add that other init configuration that we saw in our documentations, right? We're going to go ahead and grab this chunk, and it will sit at the same level as kubelet extra arg. Well, it'll sit at the same level as like node registration and those sorts of things. So let's go ahead and drop back over to number 3. Here's our node registration section. Add a new line. We'll paste, and we'll fix our tabs. So this sits at the same level as node registration. Of course, it's a list. Terrible tabbing. All right. Phases. Oh, didn't quite get that right. So now we have. Oh, well, wow. Don't mess with me, huh? Oh wait, no, I had that right. You. Okay. So same level as node registration. We're going to skip the kubeproxy add-on. And we're only going to do this for the kind no proxy cluster in the kind no proxy namespace. So let's go ahead and apply this one now. And no proxy. Okay, and while we're waiting for that to come up, we'll do dear proxy and we will move into the kind proxy directory and we'll do I'm just going to use a tool that's called dearenv to make this easier for us to manage. So I'm going to do dearenv edit dot export kube config config equals e config. Wow. Okay. We'll copy that kube config from kind proxy to kind no proxy. Wow. Okay. So then we're going to do cluster kettle get kube config -n kind proxy and we will we'll output that as kind proxy kube config. We'll do the same for no proxy. And then if we move into either of those directories, we should be talking to only that cluster. Look at nodes. There's our kind proxy nodes. And if I move back into kind no proxy, it'll get nodes. Works a champ. But for some reason, the worker nodes are not quite up yet. Oh, you know what this is? Because I've run into this before. This is a good time. And .6. There is a great, excuse me, itchy eye. Okay. Known issues. Too many input files. Copy. Hey. Sorry. So what happened there? We're only on the same, we're on one kernel, right? And that one kernel has a max user watches of a much lower value than this. Also has a max user instances of a much lower value than this. And so in so doing, it basically limits the number of, when you create a Docker, a kind cluster, you actually use up a bunch of those. And so if you're going to create multiple kind clusters, then you got to come up with a solution for solving that problem. If you're using kind, if you're using like VMs, like if we were doing this in the KubeVirt side of things, we would not have run into this problem. This is a problem specifically for kind. So now we can actually see all of our nodes. Ammo. All right. So then let's play with that Cilium CLI again. That's what we're here to do after all. So let's go back into kind proxy and we'll do Cilium install. And we can see that in the kind proxy that it detected that the version of this cluster is a kind cluster, that it's running version 14. We're going to do the same install. So this is very similar to what we saw the install on the management cluster, on the cluster API CAPI management cluster that we're running. And we're going to go ahead and install Cilium here, and then we'll go over to the kind no proxy, and we'll do the same thing over there. Here we will see a difference. Cilium install. What happens here? So in this case, we detected that it was a kind cluster. We detected that the name was kind no proxy. We detected the data path is tunnel. We noticed that kubeproxy has not been installed. We made the decision that Cilium will fully replace all of the functions of kubeproxy. Hey, how's it going? Good to see you. And then here is the difference in our template. Right? So in our template, we're saying helm template, namespace cube system, Cilium. We're going to do K8's service host is 172.18.08, the K8 service port. And we detected this from the kube config that was passed into Cilium. We're going to set kubeproxy mode to strict. So here is an example of that difference between the way Cilium actually detects these things, right? So in this case, the Cilium CLI detected that there was no kubeproxy, and it went ahead and deployed it in such a way that Cilium is handling kubeproxy. So in this kind of no proxy cluster, we can see Cilium is installed, and we can see there is no kubeproxy. And if I were to move back into the kind proxy cluster, you can see that there is a kubeproxy and that Cilium is installed, but the status is different, right? Like the values of these things would be different. Pretty cool. Well, how does it work in VM? So actually, what time do we have? It's 11:59. Should I do this in the KubeVirt side as well, or should I leave well enough alone in this example? What do y'all think? You want to see some KubeVirt action, or do you want to call it a day and start kicking into our weekend? What do y'all think? I'll give you a few seconds to make the decision. KubeVirt or no KubeVirt? I know, pop quiz. You're probably just listening to my voice. Shall I do some cluster API clusters that are leveraging KubeVirt and do the same test and kind of show how that works in just VMworld, or should I call it a day? Bum, 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 bum. First answer gets it. Going once. Going twice. Let's go. All right, Sergio, let's do it. Okay, so I'm going to make here, and we'll call this KVirt proxy and KVirt no proxy. And we will do generate arc to arc. Maybe it's down here in this history. KubeVirt. Okay. Do a copy of that. We'll go ahead and start watching our machines again. Clear. And then what we're going to do is we're going to do a paste of that. Right. I'm going to call this one, because we're actually using a different type of cluster here, I'm going to call this KVirt proxy. LB, machine code 1 and 1. We'll do keyword proxy, keyword proxy. And we'll make one that is no proxy. And then we'll edit keyword no proxy. And we'll make our changes inside of here in the init cluster or in the init configuration. There we go. Inside of here, we're going to do skip phases. Add on Q proxy. Try to have that correct. No proxy YAML. Oh, it's just add-on, not add-ons. Chunk. Okay. We've got our clusters. We can kubectl get ns. Make sure we create our namespaces. We'll do kubectl create ns keyword proxy keyword no proxy. Got our directories already created. cp kind no proxy dot nrc to keyword star dot. Hello. Okay, let's go ahead and create those clusters now and see if they get generated. So we'll do kubectl apply -f keyword proxy.yaml. Alabama. Machines getting created. These will be VMs. These will be KVM virtual machines that are going to be running here. Once they become available, we will look at how they work. So it's going to be a little bit different than the old ones here. Because before we were creating Docker clusters, we all share the same kernel. We all all of these are just running as Docker containers. If I were to do Docker PS here, we'd be able to see all of those clusters running, right? So there's our kind no proxy, one of our deployment nodes. There's our control plane node. There's that management cluster that we're running with all of the data in it. And then there's our kind proxy LB. And here's our cluster worker and our cluster control plane. That's our management cluster. Sorry. Okay. Waiting for this guy to come up here. You know what would be fun? I'm actually really curious about this. This is a beast of a machine, right? It's got lots and lots and lots of CPUs, 64 CPUs, tons and tons of RAM. Wanted to see what this looks like load-wise. We're not really hurting it too much yet. It's not really feeling it. Available is 94% on the RAM. I/O is looking good too. Everything's looking great here. Still provisioning. Wait for this to get finished up. And actually, while we're waiting, I'm going to go ahead and kick up that other one so we don't have to wait as long for the second one. No proxy. So that should get, hey, there looks like our control plane for KVirt proxy just came up. KVirt proxy. We'll do the cluster kettle at kubeconfig -n KVirt proxy. KVirt proxy, get nodes. Hey, one of them is ready. Control plane's node's there, but the worker nodes are not yet ready. Makes sense. Takes a little longer. Virtual machines. There we go. There's the control. There's the worker nodes. Excellent, excellent. Just waiting for those KVirt no proxy ones to get going. Oh, looks like the control plane for KVirt no proxy just came up, which means I can do cluster kettle, get kubeconfig -n KVirt no proxy. Kettle, get -n proxy. Config. And then we can see it'll get nodes, control plane node, pods, -a. No kube proxy was deployed. All seems to be working. Still waiting on that other node. There we go. All right, so now we are ready to do the Cilium install on these two clusters and see what we see. So let's play with that. So let's do it on the proxy one first. Cilium install. What did it detect? It detected the name. It set a data path of tunnel. It detected that kube proxy was installed. It did not detect that it was a kind cluster. It just, it doesn't really know much about this cluster. So there's not much for it to learn because it just looks like a standard, bunch of machines. But it goes about doing the work like it did before. Disabling kube proxy replacement because it detected that kube proxy was already running. And away we go. We do Cilium status. Cilium is installed. Kernel get pods -a. And that is the story in KVirt proxy. Will it work in KVirt no proxy? Go. So Cilium 112, KVirt no proxy, tunnel, auto detecting kube proxy has not been installed. Cilium will fully replace. It detected the IP address and service port, again, from that kube config that we're using to interact with the cluster directly, and went ahead and set it as completely set up. You may recognize this IP address. This IP address is actually part of that VIP setup that we created. Okay, and if we do Cilium status, see everything's deployed. get pods-8w. No proxy, Cilium is deployed, and all of the things are working. How do we know that all of the things are working? Test. What to do with just a light. Cilium connectivity. This thing that what do you call it? Hubble's not been enabled in this cluster, so we're just doing some validation tests. That all the things work service-wise and external traffic-wise. All right. And that, my friends, is how we do it on Friday. We've got 4 clusters running. We've got 2 kind clusters. We have 2 KubeVirt clusters, all running either in kubeproxy mode or without kubeproxy, all managed by Cluster API. We can kind of see how all of these things are working. We can scale them up and down. We can do all kinds of fun stuff. And all of these things, and the connectivity tests seem to be working across the set as well. So pretty fun stuff. I think next week or next time we meet, I'm probably going to be talking about how we can use things like Flux to manage the configurations of deployments on these clusters. And so we're going to kind of dig into those things and start playing with those. I hope you all have a wonderful weekend, and I hope that the end of the year is treating you kindly and that you're having a wonderful time. And I'll see you all next time. So thank you for tuning in, and thank you for being here with me. And I will see you all next time. Great day and a great weekend. Bye.